and welcome. Today I'll be explaining the solution of longest palindromic substring. So I wrote out an example string right here, and just quickly eyeballing it, we can see that the longest palindromic substring in this string is right over here. But we can also see that there are other palindromic substrings, like here and here. We know we need to keep track of the longest palindromic substring as we go through this string, and update longest whenever we find a larger palindrome. And with palindromes, it's important to note that palindromes mirror around its center, but there are two cases for the center. So palindromes mirror around its center, and there are two cases for the center. So the first case is we have an even amount of characters for this palindrome. So if it's an even amount of characters, like A, B, B, A, its center is these two characters. So let's just point to it. Its center is these two characters. We check, okay, are these two characters the same? Yes. Move this back by one. Move this up by one. Check, are these two characters the same? Yes. Move this up by one, and then move this back by one. And then here we'll hit null, and then we'll just return this as a potential longest palindromic substring. Another case for the center is odd amount of characters. For example, if we had a palindrome like A, B, A, sorry about the periods. So if we have an odd amount of characters, the center will just be this single character. So we'll just have two things pointing to the single character. And now let's just move this back by one, and at the same time move this up by one. And then we see, are these two the same? Yes, continue. Move this up by one, move this back by one, and then we see, oh, we hit null, and then we'll return this as a potential longest palindromic substring. And then we compare the two, see which one's longer, and we'll update longest as needed whenever we find a longer palindrome. So that's the general idea of the solution here. Let's just quickly code this out. So first we're going to go over our edge cases. So string.length is less than 1, or we'll just return an empty string. Now we need to keep track of longest and update it whenever we find something longer. Now we're going to go through this string. And so we'll say let odd palindrome equals expand from center. And so we're going to say the center is I and I, just like over here we have two pointers pointing to this. This is the center. So the center will be the same character. That's why it's I and I. Now even palindrome, let's assume even palindrome, expand from center. Let's do I minus 1 and I. So here, the reason it's I minus 1 and I, the center is going to be two characters next to each other right here. So I minus 1 and I are next to each other, so that's what represents the center, these two characters. So for odd, the center is one character. For even, the center is two characters. And then we're going to have a function called expand from center. So expand from center is just going to move these up, move this back by one, move this up by one, and just basically keep expanding until it violates the definition of a palindrome. So I'm just going to keep expanding up by one, back by one, and that's basically what expand from center does. So expand from center is going to return two strings, and now we're going to compare which one is longer. So you could take the maximum between these two and compare to longest, or you could just say odd palindrome dot length. If that is greater than our current longest dot length, we'll update longest to being longest equals odd palindrome or if even palindrome.length is greater than longest palindrome.length, let's update longest to being even palindrome. And then at the very end, we return longest. Okay, so now I'm going to do expand from center, which we're just going to keep expanding until we either hit null or we hit two characters that are not the same. So like say we have like A, B, A, B, B, A. And let's say we just have a pointer here and here. And then we'll just check these two. Are they the same? Yes. Expand by 1. Check these two. Are these the same? Yes. Expand by 1. Check these two. If they're the same, expand by 1. And then we hit null, or maybe we hit a character that's not the same. So then we move this back by just 1. And we'll return this as a potential longest palindromic substring. Okay, so let's just write this out. So while left minus I and left minus I equals right plus I, keep expanding. So as long as this is valid, we're just going to keep expanding by 1. Now, this basically means, as long as we don't hit null, and we'll keep expanding as long as these characters from the left and right side are the same. Okay. Then we're going to return slice left minus I, right plus I plus 1. Now just remember the plus 1 is because for dot slice, it includes this value up until this value, so it excludes this value. So we have to add by 1 to include this. And let's run the code. Oh, sorry. Okay, and submit. Okay, and just real quick, the time complexity of this would be O(n) squared, and the space complexity would be O of 1, constant space. Yeah, I hope this helped, and thank you so much for watching.